Hello all, good morning, good afternoon or good evening, whatever the time is. Today we're going to discuss about another one important and interesting session of organic chemistry, nucleophilic substitution reaction. And here is your Ravina, and this belongs to the NCERT chapter class 10, Haloalkanes and Haloarenes. And what do you mean by this SN1 reaction? What do you mean by this SN2 reaction? What is the substitution nucleophilic, bimolecular and unimolecular? Okay, so today we're going to discuss all these. So before moving to this in detail, please click on the subscribe button Chemflix if you are new to this channel, and also I'm welcoming you. Sorry for this. And okay, and if you like this video, smash the like button and so share among your friends, because it's a very important topic of organic chemistry. Okay, so what do you mean by this nucleophilic substitution reaction? Let's see in this detail. So nucleophilic substitution reaction is the reaction in which a nucleophile replaces a halogen atom. Okay, since we are dealing with haloalkanes and haloarenes, there is a halogen atom. Of course, there will be a halogen atom, and this halogen atom is the leaving group. Okay, and the nucleophile which is going to attack this one is the attaching group. Okay, so this nucleophile, it is attached to this alkyl halide, and here the halide is the, or a halogen is the leaving group. Okay, so that is what actually happening here in a nucleophilic substitution reaction. So before that, what do you mean by this nucleophile? Okay, what is this nucleophile? What do you mean by this nucleophile? So nucleophiles are electron rich species. Okay, nucleophiles are electron rich species. So there you can see a negative charge which is attached to this. Here you can see nucleophile, for example OH minus, for example CN minus, for example also ammonia is also a nucleophile, NH3, because it possesses a lone pair. Okay, they can donate this lone pair to another species. So that is what is called this nucleophile. That is, they are nucleus loving. Nucleus loving means, what is the charge of nucleus? Nucleus is in positive charge, so of course there should be enough electrons to attract this positive charge. So the nucleophiles, what is the charge of this nucleophile? Nucleophile should be a negatively charged species. Okay, negatively charged species, or it has the ability to donate the electron pair. For example, in the case of ammonia, it possesses a shared electron pair, shared lone pair, so it can donate this electron pair towards this. So these are the examples, some of the examples of nucleophile. So this nucleophile replaces a halogen atom. So that is what is happening in the nucleophilic substitution reaction. Clear? Now the order of the leaving group. Okay, for example, if I'm talking about CH3 fluorine, okay, another one halogen, CH3 chlorine, methyl chloride, CH3 bromine for bromomethane or methyl bromide, or CH3 iodine. Okay, that means iodomethane or methyl iodide. Okay, what is in the case? The order of leaving group. How this leaving group? Okay, how this leaving group? Okay, which is more effective leaving group here? That is what we are going to discuss now. So here, this iodine, okay, iodide ion, okay, iodide ion. So this is the size of the iodine ion is very okay, moving down the group. As we know, moving down the group, the size of the atom increases. So here iodine atom is the bigger atom. Okay, the size of iodine atom is very large compared to fluorine. So the order of leaving group is iodide ion is greater than, bromide ion greater than, chloride ion and fluoride ion. So the fluoride ion is the poorest leaving group among the halogen because it's very small. Okay. So that is what all about the nucleophilic substitution reaction in a brief. Next we are going to see about some common nucleophilic substitution reaction. Okay, some common nucleophilic substitution reaction. Okay, so I will show you. Okay, OH minus, sorry, I'm just going to change the color of my pen because okay, so OH minus, OR dash minus, OR minus, CN minus nitride, hydroxyl, or SH minus, SR dash minus, NH3 which possesses a lone pair, RCOO minus. These all are examples of nucleophile. These all are examples of nucleophile. So whenever this nucleophile comes in contact with an alkyl halide, you know that this one is alkyl halide. Whenever this comes in contact with the alkyl halide, what happens here is substitution occurs. Okay, substitution occurs. So here you can see when Rx come in contact with the OH minus, this X minus, that is the leaving group. So here is the halide, is the leaving group, and you will get ROH as the product, alcohol. And in the case of here, ether. In the case of when Rx comes in contact with this nitrile, you will get nitriles. Okay, CN, nitriles. Okay, then SH minus you will get mercaptans, and SR dash you will get sulfides, and RNH2 amines and esters. Okay. So these are some of the common nucleophilic substitution reactions just for an introduction. What is actually nucleophile and which are some of the examples of nucleophile. I think it's clear for you, isn't it? Okay. Now, let's see about the mechanism. Okay, how this nucleophilic substitution is happening, how it's going to happen. So the nucleophilic substitution reaction takes place or proceeds by two different mechanisms. The first mechanism is SN1 mechanism, or it can either be SN2 mechanism. Here N is the subscript and 2 is the superscript, and here N is the subscript and 1 is the superscript. Okay, here 1 represent simply it is the rate. Okay, rate of the order of the reaction. And here 2 represent the order of the reaction. Here N represent it is nucleophile and S represent it is substitution. We can see it in detail. So the first one is substitution nucleophilic bimolecular. Bimolecular, that is what exactly this 2 means. Bimolecular. Okay. So what is the substitution nucleophilic bimolecular reaction? So here when 2 molecules take part in the determining the rate of a reaction. So we already studied in your chapter 3 chemical kinetics. Okay. A rate of the reaction. Rate of the reaction. Okay, how can you write the rate of a reaction if... Okay, so here rate of the reaction, how can you represent the rate of reaction? Rate is equal to K into concentration of A to the power 1 and concentration of B to the power 1. So here, order, what do you mean by order? Order is the sum of the powers of the concentration terms. Okay, sum of the powers of the concentration terms in the rate determining step. So here the order will be 1 into 1 plus 1 is equal to 2. Okay. Okay. So the rate depends on the concentration of both of the reactants, and it follows the second order kinetics. For example, the reaction between CH3Cl, that is methyl chloride, and hydroxide ion to yield methanol and chloride ion. I will show you what exactly this means. So here I am going to represent this by using the example methyl chloride with OH minus. Okay, so I am going to draw an OH minus ion here plus methyl chloride. I am going to represent it as a wedge dash representation. So here this is the hydrogen that is pointing away from us, and this one is a hydrogen that is pointing to us. Okay. This is the wedge line, okay, and this one is the hydrogen that is in the plane of the paper, and this one is our methyl chloride, okay, chloride, okay, this is also in the plane of the paper, okay, chloride. Okay, so what happens here is, okay, in SN2 mechanism, the incoming nucleophile, so this one is the nucleophile, okay, the incoming nucleophile approaches the alkyl halide molecule and starts interacting with them. Okay, and the carbon halide bond, this one is the carbon halide bond. I will indicate using another one color. Okay, thickness. Okay, this one is the carbon halide group. Okay, carbon halide bond starts breaking. Okay, it starts breaking, and a new carbon nucleophile bond. Okay, this one is the carbon nucleophile bond, that in the case here carbon OH bond starts forming. These two processes takes place simultaneously in a single step. Okay, these two processes takes place simultaneously in a single step. I will draw it. Okay, I'm going to change the color. Okay, I will draw it here. Okay, I will show you. Okay, this all things takes place in a single step. So what happens here is this OH that is approaching this carbon and this Cl, okay, this bond starts to break, and here you can see this one is the dashed hydrogen that is pointing away from the viewer, and this is pointing towards the viewer, and here you can see this one is the hydrogen that is in the plane of the paper. And after that, what happens here is, okay, there you can see an inversion. Okay, I will show you. Okay, there you can see an inversion here, that is OH, it comes in the plane of the paper, and this one is the hydrogen and this one is the carbon, and here you can see the wedge hydrogen, okay, and here you can see the dashed hydrogen. So this one is actually methanol, okay, methanol, that is CH3OH, CH3OH, and the Cl minus, it is leaving, okay, this one is the leaving group. So I will tell you. So here this two process takes place simultaneously in a single step, and no intermediate is formed here. Okay, here there is no intermediate, and as this happens, the configuration of carbon atom under attack, okay, this one attack, invert in the same way as an umbrella is turned inside out when caught in a strong wind. Okay, there you can see an inversion. Okay, here inversion of configuration, you can see an inversion of configuration here, and this inversion can be called as Walden inversion. Okay, inversion can be called as Walden inversion, and okay, so this is all about the SN2, okay, substitution nucleophilic bimolecular reaction. Okay, this is by using an example what happens when methyl chloride react with an hydroxide ion. So here the order of the reactivity, why you are thinking about the order of the reactivity, okay, order of the reactivity, what happens here is, here there is no intermediate. Okay, I am going to write it here, no intermediate is here during this reaction, that means SN2 reaction, there is no intermediate. Okay, and the order of the reaction is like methyl halide, there you can see methyl halide, there is no steric hindrance here, so methyl halide, methyh methyl halide, and okay, after that primary halide, okay, okay, and moving to secondary and tertiary, of course there is steric hindrance is there, so that means the OH minus, that is the nucleophile, is failed to attack the carbon atom. So the order of the reactivity will be like methyl halide greater than primary halide greater than secondary halide greater than tertiary halide. Okay, so this is the order of the reactivity that you need to study. Okay, so that is all about this nucleophilic substitution bimolecular reaction. This takes place in a single step. Okay, that is the conclusion. I'm going to give it a short. There is no intermediate is formed in SN2 reaction, and it takes place in a single step, and there you can find an inversion, and that inversion is called this Walden inversion, and here the order is equal to 2. Okay, that means both the reactant is taking place towards the rate of the reaction. Okay, rate determining step. In the rate determining step, you can see both the reactant, that is this nucleophile and the methyl chloride. Okay, so alkyl halide or the nucleophile, okay, though both are taking place in the reaction. So this is all about the SN2 reaction. SN2 means in SN2, here the 2 means it is the rate. Okay, here the order is 2, which means it in the rate determining step both of the reactants are taking place, and here substitution nucleophilic, and here one thing, since this is 2, it takes place in a single step, and in single step you can see here no intermediate, and of course there is Walden inversion. Intermediate, and of course there is Walden inversion. Okay, so that's all about the SN2 mechanism. Next we can see the substitution nucleophilic unimolecular mechanism. That is the second mechanism. That's how the substitution of nucleophile to an alkyl halide. So let's discuss that here. Here the nucleophilic substitution reaction, in which the rate of a reaction depends upon the concentration of alkyl halide only. here the rate of reaction, only depends upon the concentration of alkyl halide. Okay, I will show you here rate of the reaction. Rate is equal to K into concentration of alkyl halide only. Okay, so that is the order of the reactant will be is equal to 1. Order is equal to 1, that is this 1 represent. Okay, this is not happens in a single step. Okay, and here also intermediate is there, and intermediate is here, and it is not takes place in a single step. An intermediate is here. So here the nucleophilic substitution reaction, in which the rate of a reaction depends upon the concentration of alkyl halides only, thereby following the first order kinetics, is called SN1 reaction. So here it is a first order kinetics. Here the rate is equal to concentration of that particular Rx, alkyl halide only, is equal to K into concentration of Rx. Okay, and here the intermediate is carbocation. Here an intermediate is there, and this intermediate is carbocation. All these points are important. Okay, so let's see. Okay, so I will show you, for example, here, okay, let the alkyl halide be CH3 thrice C, okay, Br. Okay, this is a tertiary alkyl halide, so tertiary methyl, tertiary butyl, so this one is a tertiary butyl bromide. Okay, in this case, tertiary butyl bromide. So here this alkyl halide, when comes in contact to the nucleophile, for example this one OH minus is a nucleophile, what happens here is the leaving group, of course the leaving group, it is the halogen, and you will get CH3 thrice C OH plus Br minus. Okay, that is tertiary butyl alcohol, okay, tertiary butyl alcohol plus bromide ion. Okay, it possesses 2 steps. Okay, takes place in different steps. Okay, okay, I'm just going to change the color. Okay, and thickness. Okay, same. Okay, so the mechanism, it includes 2 steps. In step 1, okay, the step 1 is formation of carbocation. Step 1 is formation of carbocation. Okay, so carbocation, cation means a positive charge is there, and it is a carbon, and the carbon possesses a positive charge, and this is an intermediate. Okay, this one is an intermediate. Okay, so here we can see this is a tertiary carbon. Okay, CH3C, CH3 thrice C. Okay, then Br, and this one on heat, it is a slow process, and slowest process is the rate determining step. That's why we are only taking this alkyl halide in the rate determining step. Okay, so slow, you will get carbon positive charge present in the carbon plus Br minus. Okay, and this one is the carbocation. Okay, this one is the carbocation. Okay, this one is the carbocation. This is an intermediate, and here a positive charge is attached to the carbon atom. And in step 2, attack of nucleophile onto the carbocation. Attack of nucleophile to carbocation. I will show you carbocation. Okay, so this one is our carbocation, positive charge. Okay, carbocation plus our nucleophile. Nucleophile is electron rich species, so negative charge is here, and this one is a fast reaction. Okay, fast reaction, and you will get this nucleophile, it is attached to this carbon atom. Okay, so these are the 2 steps that you can see here in the SN1 mechanism. Okay, SN1, even though it is SN1, that means the rate determining step to the order of the reaction is 1. Okay, and okay, this here, what actually happens is retention of configuration. And in SN1, SN2 mechanism, we already told there it is involved an inversion. Inversion is there, and here there is no inversion, that means retention of configuration. This is SN1 mechanism, configuration. This is IGURATION, okay, and retention of configuration. So the rate of SN1 reaction depends upon the breaking of this CX bond. Okay, the rate depends on the breaking of CX bond and the formation of this carbocation. This suggests that greater the stability of carbocation. So this depends upon the stability of carbocation. Stability of carbocation. Okay, so this depends upon the stability of carbocation. So which carbocation is more stable? The more stable carbocation is tertiary carbocation, okay, greater than secondary carbocation, then primary carbocation. So in tertiary carbocation, what happens here is, okay, CH3, here is CH3, and here also CH3. So these all are electron releasing groups, so they will donate the electron pair towards this central carbon having the positive charge. So this one is more stable compared to this one, okay, CH3, okay, and which one is more stable than, okay, a positive charge, primary carbocation, and also, okay, and so on. Methyl halide. Okay, so the halide, tertiary halide is greater than secondary halide, greater than primary halide, greater than methyl halide. That is the order of reactivity. Halide, okay. This is the order of reactivity. So the thing that you should keep in mind here is, the first one is, takes place in two steps, that is step 1 and step 2. And here this one is the slowest step, so this will be the rate determining step, and in the rate determining step there is only alkyl halide. So the order of the reaction is 1, okay. So, and here you can see an intermediate is forming here, and based on this stability of this intermediate, that is carbocation, okay, the order of the reactivity will be like this: tertiary halide greater than secondary halide greater than primary halide. And here the retention of configuration, there is no inversion, that means retention of configuration is there. And for the case of allylic and benzylic, you know, this one is a benzylic, and okay, this one is benzylic, and okay, here you can see this one is 1, 2, 3, and CH2X. Okay, this one is benzylic, and this one allylic. They show high reactivity towards SN1 reaction because carbocation thus formed gets stabilized through resonance. Okay, in the case of allylic and benzylic, okay, this carbocation which is formed by this, okay, this one is the carbocation formed by from benzylic and allylic, okay, they are resonance stabilized, therefore the carbocation is more stable in the case of allylic and benzylic halide, and they go towards the SN1 reaction. That is, substitution always happens through the SN1 mechanism, okay, that is this mechanism. Okay, so that's all for today. Thank you all. And also, if you like this video, please like, I already told you, comment, and share among your friends, subscribe to my channel. Okay, so thank you all. Thank you.